In this video, I will review the answers for quiz review number 3. First problem, we are provided with a contingency table. The two variables are age group and types of investments. We're picking a person at random from this data. Part A says the person is between 40 to 49 or invest in mutual funds. So don't forget, we have to find the sum of each column, each row. The grand total is 400. So the person is 40 to 49 or invest in mutual funds. Remember, or means to add. And so we look for all the people that are 40 to 49. That's 71 out of 400. Plus all the people who invest in mutual funds, 47 out of 400. We have to be careful because we don't want to subtract the overlap. And it turns out that we're double counting all the people that are between 40 to 49 and invest in mutual funds. So that's one, because we're double counting. We're counting them here and then here. So we have to make sure to subtract it out. So minus 1 out of 400, we get 117 out of 400. It doesn't reduce. We'll leave the fraction alone. The person is 70 to 79 and invest in real estates. Whenever we see the word and, we're looking for the overlap. So we're looking for what's common between the two variables. So we have 70 to 79 real estate. So the overlap is 3. So your answer is 3 out of 400. That doesn't reduce either. The person invests in bonds or businesses. Bonds and businesses are mutually exclusive. They have nothing in common. So we can calculate the probability that someone invests in bonds. That's 88 out of 400 plus the probability that someone invests in businesses, 79 out of 400. Add the fractions, we get 167 out of 400. And then lastly, we have the person is 30 to 39 or invest in bonds. I think we will have some overlap, so they're not mutually exclusive events. 30 to 39, 56. Invest in bonds, 88. And the overlap is 8, so we have to subtract out 8 out of 400. That's 136 out of 400, which reduces to 17 out of 50. Number 2, there's 1,000 people who are selected from a convention. 490 of these people are fans of Marvel Comics. 380 are fans of DC Comics. And then we have 150 that are fans of both types. So if we pick a fan at random, what's the chance that they're a fan of either Marvel or DC? Once again, or implies we're using the addition rule. These events are not mutually exclusive. So the chance of picking a Marvel fan is 490 out of 1,000. The chance of selecting a DC fan is 380 out of 1,000. But we don't want to double count the fans of both. So minus the 150 out of 1,000. That's going to be 720 out of 1,000, which reduces to 18 out of 25. Number 3, we're looking at 2 dice are tossed once, find the probabilities. So part A is saying the sum is 7 or 11. We can use, remember, the total amount of possibilities when 2 dice are tossed is 36. So we have 7. The way we use the sample space chart is that each white and blue die represent a pair. So 1 6 is 7, 2 5 is another 7, etc. So if we count up all the pairs for 7, there's 6. So that's how we get 6 out of 36. And then 11 only has 2 pairs. So that's how we get 2 out of 36. That will equal 8 out of 36, which reduces to 2/9. And then B is saying the result is a sum that is odd and between 2 and 8. So we're looking between 2 and 8. So we're looking at all these sums here that are odd. Well, 3 is between 2 and 8. It's odd, so there's 2 chances of getting a 3. So 2 out of 36. 4 is even, so we bypass 4. 5 is odd, so there's 1, 2, 3, 4 chances out of 36. And then finally, 7 is odd. And we know that that's 6 chances out of 36. We add up all the values to get 12 out of 36, which reduces to 1 out of 3. Part C, the result is a 13. While the maximum sum is 12, it's impossible to get a sum of 13, so the probability is 0. Number 4, it says the chance that a person receives flowers for Valentine's is 43%. If a person is randomly selected, what's the chance that the person does not receive flowers for Valentine's? Well, this is a complement probability, so it's 1 minus the chance of receiving flowers, which has been converted to a decimal. So 1 minus 0.43, 0.57. We can convert the answer to a percent. Remember, just move the decimal 2 spaces to the right and write down the percent sign. The answer is 57%. And finally, number 5, if a card is selected from a standard deck, compute the following. The card is a numbered card. So let's take a look at the sample space for cards. And so the numbered cards we have, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbered cards, but there's 4 of each type. So 9 times 4 is 36 out of 52, which reduces to 9 out of 13. The card is red and a face card. So this is a roundabout way of asking for red face cards. And as the overlap, if just to recall. It also represents what's called an intersection. So we're looking for all the face cards. The face cards are these cards here, the cards that have faces. And we're looking for the red face cards. Well, there's 3, and then there's another 3, so that's 6 out of 52, which reduces to 3 out of 26. And then finally it says the card is a diamond. Well, we have 13 diamonds, or an even numbered card. Well, let's take a look at the even numbered cards. Well, there's 4, 8, 12. Let's see that. So 4, 8, 12, 16, 20. So there's 20 even numbered cards. And then we have to subtract out the overlap. Well, the overlap will be the numbered cards, the even numbered cards that are diamonds. All right, so let's go back to take a look. So remember, it should be even numbered cards. Let me just go through that one more time. The even numbered cards, I thought they were odd. They're even. So we have 4, 8, 12, 16, 20. And then we have to subtract out, because we're double counting, the 2 of diamonds, the 4 of diamonds, the 6 of diamonds, the 8 of diamonds, the 10 of diamonds. So we have to subtract out 5 to avoid overcounting. So 13 plus 20 minus 5 is 28 out of 52 cards. And that's going to reduce to 7 out of 13. Thanks for watching the video.